I will build the dashboard myself and show him.
Your lesson worked.
Assalamualaikum and hi, my name is Nadia Natsira and our group name is Strawberry Miss, and this is our SIEM group project for ITT450 using the Elastic Stack ELK. In this video, we will walk through the dashboard we built using Kibana weighted dataset and explain how they help monitor and detect cybersecurity threats. First, this big red panel shows the total number of log, which is 5480 in this case. It helps us quickly understand the size of the dataset we are dealing with during investigation. On the left, we have the outbound trade map. This map shows which countries are sending suspicious traffic from inside our network. The numbers represent how many outbound activities came from each country. On the left, we have the inbound trade map. This highlights where threats are coming into our network from external countries. This pie chart visualizes event severity. Almost half of the events are low severity, but also have significant high and medium severity threat that need further investigation. Next, we created a top destination IP address panel that shows the most targeted IPs. These are critical to monitor since they are frequently attacked. We also visualize the top source and destination protocol. This gives insight into how threats are entering, like through FTP, POP3, and DNS. This bar chart compares attack types versus count. Lastly, this stacked bar graph shows attacks over time by hour. This helps spot spike in activity and narrow down when certain event occurred. Here we have a detailed log table. It shows fields like timestamp, source IP address, destination IP address, source port, destination port, and event type like DDoS and SQL injection. This is useful for deep diving into individual logs. This completes the first part of the demo, the dashboard engineering walkthrough. In the next part, we will show how we use this dashboard for monitoring phase and real-time threat tracking.
Assalamualaikum and hello, I am Nushadatul. Now let's move on onto the monitoring phase. In this part, I'll show how my dashboard helps track network activity, login attempts and threats in real time or by selected time range. Here, we see a detailed log table. This helps us monitor real traffic. For example, we can track source IPs and their destination targets, check the event types like DDoS or SQL injection, and examine the timestamp to see exactly when something happened. If we want to investigate login attempts, we can filter the source port like 25, 110, or 443, which are commonly used for emails and secure logins. And as you can see here, I am filtering the source port of 25. And from this, we can see the event severity and the event type. This helps us identify any suspicious login events. This bar chart gives an overview attack types. From here, I can monitor that DDoS is happening at high frequency compared to other types like SQL injection or phishing. We also use this hourly timeline chart to monitor trends. It shows how events are distributed across time, grouped by type and severity. For example, we can see a spike of DDoS attacks on December 13th between 6 a.m. and 12 p.m. The inbound and outbound threat maps are useful for monitoring geographic activity. If a certain country suddenly appears with a lot of outbound traffic, it could mean a device inside our network is compromised. These donut charts show top source and destination protocols. They help monitor how data is transmitted. If we see unexpected protocols like POP3 or FTP in high volumes, it might indicate unusual or insecure traffic. So overall, the dashboard allows us to continuously monitor network behavior, track what type of threats are happening, where they are coming from, and how the system is being accessed, all in real time or by filtering through historical logs. Now, we'll move on into the detection phase, where we identify anomalies and begin the analysis of suspicious events.
Hi, my name is Narayan Farhana. So right now we are in detection phase where we analyze the dashboard to identify anomalies or suspicious patterns that could indicate security threats or ongoing attacks. So the first thing we notice from this bar chart is that DDoS attacks are by far the most frequent. That's an immediate red flag indicating potential service disruption attempts. So saying a high number of DDoS events means we need to check which systems were targeted and whether they are critical assets. If we look at this timestamp-based chart, we can detect a sudden spike in attack volume around December 13 in the early morning hours. So this is a classic sign of an automated attack or a botnet trying to overwhelm a system. Looking at the inbound threat map, we can see a large number of threats are coming from a certain countries, especially one with the 54 threats, which are much higher than others. This kind of geo-based anomaly suggests potential involvement of a known malicious region or compromised servers operating from there. So we need to click the filter, and so this is the country that have 54 counts of record. From the log table, I noticed a specific source IP, which is 169.166.109.252, is repeatedly launching DDoS attacks on port 110. That is consistent with email services, which makes it a high-risk vector. And we also see multiple events using uncommon destination ports, like port 21, which is FTP. If we don't normally use FTP, this traffic could be unauthorized file transfer attempts. So this panel shows the most targeted IP address in our networks. For example, these two IP addresses were repeatedly hit. When one IP address shows up frequently across multiple types of attacks, that is a strong indicator it's under active threat and needs protection. Another important thing is the severity distribution. We have over 26% of events classified as high severity. That is a clear sign that the organization is under active threats. So there is 1,460 counts of records. So using the dashboard visualization, I have detected a repeated DDoS attempts from the same IPs, unusual traffic on unexpected ports, spikes in threat activities within short time frame, traffic from suspicious geographic location, and lastly, critical assets being repeatedly targeted. So all these are potential indicators of compromise, and the next step is to investigate one of these suspicious patterns in more details using Kibana timeline and VirusTotal.
I am Nurfana. Now let's begin the investigation phase. Starting with the Kibana timeline. Here, I'll investigate one suspicious pattern we detected earlier during the dashboard analysis. I filtered the logs to focus on the source IP 169.166.109.252, which was involved in repeated DDoS attacks targeting port 110 on December 13th. Here we can trace the attacker's actions, the IP address, type, source, and destination port. We can also check if the attacker changed methods or targeted multiple IPs. This helps build a timeline of events and understand the attacker's behavior. From the logs, we can also see which destination IP addresses were targeted, like 23.227.3874, helping us identify the systems at risk. We can also see that this IP address has done multiple DDoS attacks, which is 11 times. I have also filtered out the destination port 21 for this attack, and we can see that these event types are evaluated. We have DDoS, brute force, normal attacks, and SQL injection. We can also see the event severity for this destination port 21, which are high, medium, and low. And you can also see here the source IP address that the attacks came from. Using Kibana, I've traced a suspicious actor's activity, identified the threat actor, and narrowed the attack timeline. Now, I'll extend the investigation using VirusTotal. Next, I'll check if this IP address is known for malicious activity by searching it on virustotal.com. I will randomly select our IP address from our dataset. Which is this one. This is flagged as malware on our dataset, and I'll use VirusTotal to see if this flag is correct. As you can see here, 9 over 94 security vendors have flagged this IP address as malicious. We can scroll on to see which security vendors have analyzed this. Most of them are flagged as malicious, malware, and also suspicious, as it has been flagged as malware, just like in our datasets. That confirms it as true positive TP. Alternatively, if VirusTotal reported the IP as safe, it might be a false positive, meaning it was flagged incorrectly. By using both ELK and VirusTotal, I completed a full investigation cycle, from detection to tracing attack to confirming if the IP is malicious. This is essential in real-world SOC operations to take the right action. That concludes our SIEM project demo. Thank you.